All right. Well, first, want to thank Abin for putting these slides together for us today. And for those of you who don't know, Abin and I worked together for about 4+ years. He was a miracle worker both on the architecture, delivery, and development for this project that we're talking about today. And he's done more miracles today. He's made me look a little bit younger and given me a bit more hair. So thanks for that, Abin. Appreciate it. Okay, so first, the problem space. So for those in government, you're all very familiar with FOI. So when we think about FOI operations where I work, we receive approximately 9,000 to 10,000 FOI requests every year, which we process on behalf of our ministry clients. So that's all the core government ministries. And in total, our analysts, we have about 150 of them. When they're processing those requests, they're primarily, the biggest thing that they do is they review the records that are collected that are responsive to the request. And they need to review those records before we release them to the applicant to make sure there's no sensitive information that we're releasing that we should not. And so in total, we are processing about 2 to 2.5 million pages per year. And so business problems that are always key to us, one is consistency. And so business problems. So there's certainly topics, whether it's COVID or something like Fairy Creek or Mount Poly, where you'll have many people making their request for the same information. So consistency about how we handle that information before we send it out to the applicant is really key. The other thing is, as you can imagine, like all of you, we are resource constrained, and what we see is that while our legislative deadlines remain the same, our actual volume of pages per request is going up. So in the last 5 years, we've seen it increase for general requests. So that's not information that's personal, but it's about general government business. We've seen each request about 48% increase in the volume of pages for each of those requests. So we need to find ways to be more efficient. And so that was one of the business problems we were looking to solve with AI. The other key, though, of course, is we want to make sure it's accurate. Right, as we all know, like when we're talking about high volumes of pages and lots even in individual requests, accuracy was also like a key goal for us. So as far as what we're doing, of course, we are guided by the responsible AI guidelines within government. So as you can imagine, we get records that could pertain to anything that government's involved in. In some cases, those are very sensitive records, including records from kids who've been in foster care. So we want to make sure that when we are doing any actions on those requests, that there's always a human in the loop, which is part of the responsible AI guideline. So our implementation of AI, I just want to underline this, there's no automated redaction process. AI is not going out and determining the information within those records that should be released or not released to an applicant. It always has that analyst oversight to make sure what the AI is finding, they make the final decision. So what have we implemented? So with our work that we've done so far, one of the key areas that we wanted to do is we wanted to handle handwritten notes. So I already kind of mentioned that we have personal records for children who've been in care. And so social workers have a practice of doing a lot of handwritten notes. And then ultimately, all those records too that come from the Ministry of Children and Family Development, most of those are stored off-site. So we actually get the physical record that we need to scan. And so one of the things we did is we're using the Microsoft Document Intelligence. We've set up a document extraction and then pointed those AI-enabled tools at those records to translate that text into searchable data, so that our analysts are less likely to miss important information. And we can say that the actual handwritten notes is a capability that we did not have previously, so it really is a game changer, particularly considering the 2 million so pages that we process per year. About half of those are MCFD requests, and they do have a lot of handwritten notes in them. Another area that we were using Microsoft for is we're using their personal information identifier. So they have a well-trained tool that just flags PII. So think about common things, whether that's emails, names, addresses, phone numbers. So we can quickly find that information, make sure that the analyst will also see it to be able to action it. And I think that's important from the consistency principle, because often what we found is when analysts are going through thousands of pages, it's actually quite easy for them to miss something that they may have redacted elsewhere in the package. We being Abin, we also did a couple custom NLP models that we're storing up in Databricks. And so those are really to find common information that the general rule is we always redacted. So IDERs would be an example, courts online records, registry records, those kind of things that there's not really a contextual decision that needs to be made. It's just a common rule that if we find that information, we can train the model to suggest that as a redaction to the analyst. And finally, preparing for the future. When context windows get bigger and the LLMs get better, we are also capturing that information that we withhold in every request. We're capturing that within our data warehouse in Databricks so that that prepares us for the future when we can actually do a little bit more as the tools get better than they already are. And I think with that, Abin, I'm going to tag you in. Yeah. Okay, Abin will tell you about the architecture next.
Thank you very much, Loren, for setting up the context for me. One thing I realize here is that I'm the shortest speaker. So this is set for somebody above 5'10". I'm only 5'8". So am I audible now? Yeah. Perfect. So don't need an introduction. So this is one of the projects is very close to my heart. I onboarded into this project April 2021 as a full stack developer, architect, delivery lead. Worked for 4 years, and I offboarded last summer and onboarded into my current project, which is Jeff's project of Agentic AI. So you heard the context, business context from Loren, right? FOI is a data-intensive system. 2 million pages, lot of redactions, personal data, protected A, protected B, and requires a lot of assistance, because when I still remember when I'm talking with one of the FOI analysts, and as part of my lazy virtual user research question, I asked, how many pages of PDF you redact or you review per day? She just told 6,000. I can't even read more than 50 pages a day. I can't even read that. She does as part of her job. Then I'm not convinced, so I just checked the old legacy system and checked the timelines, because each page has a log for us. So check, literally they are doing a kick-ass job going through these thousands of pages line by line, checking for personal identifying information, contextual data that can identify an individual in the government. That is the riskiest part. Detecting PII is like this. There are so many services in the world to do that. There is no logic we need. But to detect the contextual information or some sort of information like IDER, right? From the looks of it, it's not a PII. When my IDER is A. Antony, but somebody can easily tell who is A. Antony in citizen services of FOI, right? It's Abin. Likewise, so the PII won't detect IDERs of government. IDER is the Active Directory Account Naming Convention for people outside government. So for that, we need to develop a custom NLP model to understand the IDER, so that when we publish this document to the outside world or hand it over to the applicant, they won't identify the government employees or staff who worked on that file. Just a sample. So again, going back to my rationale, first thing is elastic compute, okay? Why I adopted a platform like Databricks or Azure AI. First thing was elastic compute. I should be able to scale it whenever I need, and I need to descale it whenever I don't need that. GPU and CPU, for sure, we trained custom models, so as a machine learning platform, we need a lot of GPUs, so we need GPUs as well. So on-premise or OpenShift Silver or MR cluster, that time when I was developing doesn't have any GPUs. Now I know the GPUs are getting added, but I'm talking about the story of 2024 or 2025. Second thing is managed data pipeline cluster. Prior to this, we had a data engineering pipeline running on-premise, which demands resources on an occasional basis, because whenever there is a hurry or when there is a big data load, we have a spike in the resources, so on-premise systems can't scale up, Also, we are managing the data pipeline clusters like Spark or SSIS or whatever. So one information I came out after after designing that on-premise system, I will never ever take a self-managed cluster because I need a managed, because my brain should be always behind, or my team's brain should be always behind solving the business problem, or I should reduce the effort or the cost to the project by making a manager, so that we don't need to patch it. We don't need to, it should automatically manage by itself, right? That's why one rationale was always goes to a managed data pipeline. Third one, built-in BI and ML integration, because most of you know that OCIO, we have the Power BI license comes default. So I need a system which has default integration with the leading BI or data analytics tools. Fourth one is the Lakehouse. So as I told, FOI is a data intensive system. We have our transactional data. We have our kind of line of business documents, which comes as PDF. Mainly FOI deal with records. So an applicant might ask, hey, what is the minister's calendar between these two dates? What are the emails this minister or deputy minister has been communicating with this particular person between this date, the usual things. Or what is the project budget, how offset the budget has been. So this involves thousands of pages, right? And when I look at it, we don't want the data, which is the raw data, sitting outside the system. We need the raw data, process data, and the analytical data sit in the same place in one platform. That's why Lakehouse architecture we have built. That made us very much effective in a monetary basis as well, because whenever we move data from one system to another, or from cloud to on-premise, there are a lot of data ingestions happening in the network, and that's what we end up paying more. So I need a single system to process the data for machine learning, for analytics, and for other AI processes. So based on these design rationales, we arrived at in this architecture. This is a very small architecture I just made for this presentation. FOI is basically a 60 plus microservices on-premise and cloud together. Here, I just curated, so what you see on the bottom is another 60 plus services. So that is sitting inside OpenShift Silver cluster of BC government. The top one is the managed, which is running behind BC government guardrails of Azure. So what you see over here is that the documents, which is like all the governance document as part of the FI request, is from our BC government object storage. That will be ingested to the Azure cloud, and data extraction happening, as Loren mentioned. We are using Azure AI document diligence, and we are using Azure NLP services to parse the data, detect the PII, the normal PIIs. And at the same time, we have Azure Databricks playing a picture over here. All the transactional data, line of business informations, are sitting inside our enterprise data warehouse. And there is medallion architecture. We have followed our Azure Databricks, where the raw data and the transformed data and the gold data for our Power BI to work on. And we also hosted our custom NLP model in Databricks, and the endpoint has been plugged in to our Azure AI NLP services. That's how it landed up in FOI Modern Apps, the front end. So I know it's a bit complicated. Let's get into the tools, and then I will have a demo in the last. So these are the frameworks we use. We use Databricks. It has Delta Lake inside. People who don't know about Delta Lake, that's a Lakehouse architecture from Databricks. We write our code inside Python notebook, and the cluster, the managed cluster, is again a Spark running inside the Databricks, Azure Databricks cloud. And endpoint is into Power BI. And we onboard our data into Azure Data Lake, which is getting ingested into the raw layer of Databricks. Let's quickly get into the demo so that a lot of tech talks will get solved. So this is our, let me pause. This is our FOI dashboard. This is how FOI analysts in the provincial government see the FOI, because they manage their day-to-day life, day-to-day kind of requests assigned to them. Let's fast forward. 'Cause last year on the same podium, I explained about the same thing for the Azure AI data extraction. Here we will show about AI things more. So this is how the detailed, the FOI request details look like. All the metadata inside. This is our line of business data. Now we will quickly go to the records. That's the end result which we package to the applicant. So here I use some kind of mock data which resembles few of the use cases which we have across the ministries. This is our document reviewer app. This is our microservice. Yeah. So here we have a document which has IDers inside. We have a screen image from a mobile screenshot. So MCFD do have a lot of, let me take a pause over here. MCFD do have a lot of mobile screenshot whether we need to detect the PIIs inside. So I took an image. So what's really happening behind the scene is somebody upload the image, it will convert it to a searchable PDF, and the data is passed to our remote NLP services, and that will detect the PII. So here you can see it detected the credit card number and the name in the image, and this will alert. Think about a situation of 5,000 pages or 4,000 pages, right? They need assistance on detecting the PIIs inside. That's the first thing. So now I'm just fast forwarding to the check. It detects the addresses, name. Now here it goes with the IDAR. This is where we actually return the custom NLP model. As you see, the name is, let's take one name, Matthew Prodden. He's our product owner. This is his IDAR. So the regular PII services won't detect that. So we need to create custom models to understand. And so we gave the samples of around 19,000 government IDAR. So our model understand the pattern of IDAR making within different ministries, and it will predict, hey, this can be a PII. That's why it's suggesting that highlight. And this is how next step it will show based on this highlight. The FOI analyst will mark the sections, FOI per sections on it. And this is how review has been done. So as quoting Loren's word, we are not replacing humans. We are using the potential of AI for the users to review the documents faster than ever. Yeah, that's mainly it. If you have questions, I'm ready. Yeah.